This represents the JMP Design of Experiments menu. At first glance, it appears as a sprawling, complex tree of options. With dozens of specialized platforms, selecting a starting point can be a challenge. However, these options resolve into two distinct vertical columns: design construction platforms for building the experiment, and supporting platforms for evaluating and refining it. For those needing a guided experience, JMP includes Easy DOE. This platform navigates both columns for you, providing a step-by-step path through the design and analysis phases in a single interface. Successfully using these tools is a matter of identifying the physical and mathematical constraints of your experiment. Once those constraints are defined, the menu acts as a map to the specific platform required for the job. Custom design defines limits and disallowed combinations, grouping hard-to-change factors into split plot blocks. Definitive screening requires 4 factors to identify nonlinear curvature and interactions. To fit quadratic models, response surface provides 3 settings, unlike a standard screening design's orthogonal grid. For cases where you must test every possible interaction, the full factorial platform generates a run for every combination of settings. While thorough, the number of runs increases with every factor level, which can quickly strain a budget. Choosing the correct platform ensures the data reflects the complexity of the process. The wrong choice results in either missing critical interactions or spending resources on more runs than the study requires. Mixture designs are used for formulations where the ingredients must maintain a constant sum. When the proportion of one ingredient increases, the platform automatically adjusts the others to keep the total at 100%. While Taguchi arrays are available for signal-to-noise analysis, JMP also allows for combined arrays within the custom design platform. This approach integrates control and noise factors, which often provides more detail for the same number of runs. For consumer research, choice design identifies preferences by grouping product attributes into sets for respondents to compare. To obtain a clearer ranking, MaxDiff forces respondents to identify only the most and least preferred options in a set. Specialized tools address different systems. Covering arrays test software combinations, space-filling designs model deterministic computer simulations, and accelerated life test designs use extreme conditions to predict product reliability. These platforms apply specific mathematical models to diverse problems, whether you are debugging a network, developing a chemical formulation, or testing mechanical stress. Consider a scenario where you are optimizing a liquid product. If your requirement is that the total volume of all chemicals must always equal 1 liter, which design platform should you select? This requires a mixture design. Standard designs treat factors as independent, but the mixture platform accounts for the fact that these ingredients are mathematically linked by a constant total. Once a design is constructed, you move to the supporting platforms. The Evaluate Design tool acts as a diagnostic dashboard. It uses an alias matrix and correlation maps to identify potential biases or weaknesses before you begin physical testing. If the evaluation shows that more data is needed, Augment Design allows you to add runs to an existing set. You can inject center points or replicates to improve the model's accuracy without discarding your original work. Finally, Compare Designs and Sample Size Explorers provide a logistical check. They allow you to see how different designs perform against each other and determine the minimum number of observations required to achieve statistical power. This sequence, moving from construction to evaluation and augmentation, creates a repeatable process for generating reliable experimental data. This mapping summarizes the workflow. For flexibility, use custom design. For nonlinear effects, use definitive screening. For formulations, use mixture. By matching the platform to the physical constraints of the experiment, you ensure the design is optimized for the task.